And we are live. Hello, my friends. Welcome
Hey, hey,
back to
hey.
the Kotlin webinar series about the server-side development. I'm Anton Arhipov. I'm from JetBrains. And I have Oleh Dokuka today with me, a member of Project Reactor team and maintainer of RSocket library, right, Oleh?
Yeah, all good, all correct. Yes.
Perfect. So today we are going to cover a brand new tutorial we just published about Spring, Kotlin, and RSocket. And but before we get started, I want to do a few announcements. Let me share my screen. So let me switch back from that pretty tutorial and explain what we are doing here. So I said that we are restarting the webinars now again. We did 3 webinars about Kotlin with Kafka, Google Cloud, various frameworks, gRPC, and now we are restarting it again. And this webinar is the first one in the series. So it will be about using Kotlin with Spring WebFlux, Kotlin Coroutines, and RSocket. And the next one coming in March, we have building microservices with Helidon and Kotlin with the member of Helidon team, Dmitry Alexandrov. And later in March, we will have a meetup about Ktor. We want to introduce Ktor more in this series. And after that, we will actually have another stream about Kafka with Ktor and Kotlin, triple K combo for you. So the tutorial that we are talking about today, we just published it 2 days ago, Oleh, right?
Yes, exactly.
Yes. Perfect. So we have this brand new tutorial. It's a pretty long one. We have 5 parts in that tutorial, but the first 3 parts are about basically setting the project up, generating this new project, adding persistence, integration tests, and basically adding and using more Kotlin features in the Spring application. These are basically the classical kind of parts that you need to get started with something, like basically like a hello world application, but it's a fully featured application. And for those parts, we already have a minified version of the tutorial on our new YouTube channel. So if you haven't heard about it yet, youtube.com/Kotlin is the new Kotlin channel by JetBrains, where you can get all kind of news and videos and presentations about Kotlin, including of course, this webinar itself. And we are uploading the new short videos as well. My colleague, Sebastian Eigner, is building a series about Kotlin Standard Library, and the other colleague, Kate, is talking about KMP, Kotlin Multi-Mobile Projects, multi-project mobile, or however you spell it. I'm always confused, actually. And there is a little series by me, Springtime in Kotlin, where you get this minified versions of this very same webinar that we are talking today. Today we are going to talk about the specific part, like the refactoring to Spring WebFlux with Kotlin Coroutines. Oleh is going to explain how you actually migrate from the classical MVC or like Spring Boot application, where you have all kind of blocking IO calls, to this reactive stack, the new reactive stack with WebFlux and coroutines. And of course, we are going to add RSocket to the mix to get a full streaming support. So about the project, so you have all the instructions in this tutorial. Like you have this GitHub repository, and if you want to go over step by step, trying all the things from this tutorial, you're going to clone this repository. There are multiple branches in this repository. Let me navigate you a little bit. So there is initial branch, which is basically the initial version of the application that we are going to work with. It's a chat application, but it's a fake one. Basically, it generates the fake messages. generates the fake data, and step by step you are going to learn how to add the database support, how to refactor it a little bit, write more idiomatic style of Kotlin, and for each part there is a dedicated branch. So if you are going to follow the instructions on every specific branch that is in this application, how you start adding new code, start refactoring the new code, and you get confused, you always have the possibility to actually compare to the solution branch. Like for part 2, there is a branch called part 2, and you will be able to compare if you did something, like if you made a mistake, or if you missed something, there is always a way out for you. All right. So the application itself, it's a chat application, as I mentioned. It's like the classical 3-tiered application where you have a browser as a client. There will be a HTML controller, basically the part that serves the UI. There is a service, of course, that has 2 implementations. The first implementation talks to the database. The other one generates the fake messages and just pushes them, or actually prepares them to be collected by the UI. So it's a polling mode for the UI in the first state of the application, the first version, when you pull it in and start it. And you will see when it already runs, like in the instructions we have it, we have this animated GIF that demonstrates the initial version of the application when you download it. So just basically generates the messages, and the UI polls for the messages and renders them as they come. All right. So I hope I covered everything that I wanted. We mentioned the webinars, so subscribe there. Then we mentioned the new YouTube channel. Please subscribe as well. And if you have any feedback, please leave the feedback in the comments to the videos. We are reading it. We are really keen on getting the feedback and improving our content. And of course, the tutorial itself. So there is a Spring Guides page, right? So if you go to the Spring IO/guides, you will find this very same tutorial at the bottom of the page. At the very end, there is Spring Boot with Kotlin and RSocket. And today we are covering the last 2 parts. And with this, I'm giving the word to Oleg, and he will explain it further, how we start using the application and why should we migrate to reactive stack as well.
All right. Thank you for this.
One more thing, as usual. One more thing. I'm reading the comments as Oleg is actually presenting the stuff. I'm reading the comments. I will try to answer the questions. If I need to interrupt Oleg, I will do that immediately and ask him the question, or I will actually find a good moment for that. So if you have any questions, please type in the chat. And okay, let's start.
All right. Thank you for that pretty intensive and broad intro in our tutorial that we've been working on for a pretty long time. And yeah, thank you for having me, first of all. And but when I started thinking about the part that we'll be showing today, I just remember that a couple of years ago I was showing pretty similar kind of tutorial where I shown how to migrate from imperative web MVC in Java, of course, to reactive WebFlux and Project Reactor. And you may take a look at this presentation. There are a couple of videos from different conferences, but by taking a look at this one, you will probably see how Kotlin is much better than Java. And during this presentation, I'll explain why it's simpler to use Kotlin to migrate your Spring Web MVC application to Spring WebFlux and even further. So with that, let me do first a short intro of what we are going to do today and why we basically migrated. So as Anton mentioned, we are building a chat application. And this chat application is pretty straightforward. So we have like three tiers: HTML, controllers, message controller. Both of those controllers are talking to kind of to a middle layer, which is message services. And message service is basically talks to message repository, which is talking itself with JDBC and the database. So the communication itself looks like the following. So we do a first one-time call to HTML controller, and basically we need to do that call in order to retrieve the HTML view, which is going to be rendered by a browser. And then we need like this part also goes to the database and takes the latest and messages that we can configure, and returns it back. So the whole page with the first few messages are rendered on the screen. Um, then basically, as you've seen, the messages appears over time, and different users can communicate with each other. We need to talk with our server for a few more times. Basically, we need to talk all the time the page is open. So it's kind of many times communication between our browser and server. And in that case, in that scenario, we are going to message controller, and message controller goes further to go further with to message service, message repository, and so forth and so on. And the main difference is that this is a really periodic call. We need to do that continuously over time, because new messages appears. And since we use this kind of pooling way of getting data and from our server, we need to check again and again and again, and use some, for example, mechanic in order to make sure we are getting new messages. And yeah, we basically retrieve messages since some period of time, which is some implementation details, but I guess you get it. So this is how our application works. And it's pretty common applications which you and me are building on today. So the main question, what's wrong with that application? As Anton mentioned, the base part, which we're gonna start with, is Spring Boot, Spring Web MVC, Spring Data JDBC, and all these words just means that even though we are using Kotlin, we are using fully blocking communication between our client and server, which means that we have blocking IO between our web server and our browser. We have blocking IO between our message repository, so between our basically server and the database. And this is not a good part. And I'm not going to be kind of explaining in details why blocking is bad, but just take it that blocking for really heavy IO or IO bounded applications is a really bad thing. And you may search for 10k 100k problems in order to understand why it's bad, but the answer is you should use non-blocking IO if you want to have really efficient web server which sends messages over IO back and forth. So what shall we do? Fortunately, Spring offers a couple of solutions for that. And basically, this part, which is offers this solution, call it basically Reactive Spring, or well known as Reactive Spring. And Reactive Spring offers a few modules, like for example, a sync functional kind of style of writing your code using Project Reactor. So basically, Project Reactor is implementation of reactive streams. And Project Reactor offers a couple of types like Flux and Mono in order to write down your business logic in a functional way, which works asynchronously and fully and fully non-blocking way. In turn, in order to serve your data and send data and receive data in non-blocking fashion, Spring utilizes Netty, and it utilizes specific version kind of, or a superset project on top of Netty, which is called Reactor Netty, which allows you to consume data as a stream and send data as a stream back and forth, which is of course details of the implementation, but from the Spring API you just need to use Mono and Flux. And finally, there is a kind of non-blocking version or non-blocking specification for JDBC, like it's non-official from I don't know, from the Java standard. It's just an initiative created initially by VMware folks, by Spring team, and then standardized and provided like an SPI and different implementations and basically drivers for different databases. And this project is pretty stable as of today. So it's called R2DBC, or reactive streams, or reactive database access, or database connectivity. So basically, yeah, I'm sorry. Need to, yeah. So basically, we have 3 projects which allows you to write your code in non-blocking way, but unfortunately, you have to migrate your imperative code to Project Reactor, which is not always a good solution. So what shall we do? Can we use imperative style and write asynchronous code and non-blocking code? Fortunately, the answer for that is yeah, Kotlin. But basically, as I mentioned, Spring offers this 3 modules which we can use and can utilize in our application. And as I mentioned, using Kotlin, we can achieve even more, because, as you may know, Kotlin offers asynchronous imperative style, or asynchronous imperative coding via coroutines, and at the same time, Kotlin has Ktor, but this time we're not going to be using Ktor, since Spring doesn't support Ktor and Ktor, and we are interested in using all Spring functionality, but get even more benefits using Kotlin as a way of coding. So, in general, Spring loves Kotlin, and that's why there is pretty good integration between Spring and Kotlin, and we can use all the mentioned model with Kotlin support. So we can use Spring WebFlux, and Spring WebFlux brings Kotlin extension, which let you use coroutines and the same imperative code style, and it offers Spring Data R2DBC Kotlin extension. So yeah, there is full-fledged integration between Spring and Kotlin. So basically, our migration from Spring Web MVC to Spring WebFlux, from Spring Data to JDBC to Spring Data R2DBC, taking into account that our application is already written with Kotlin, should be as easy as pie. So let's have a look at that. All right, so this is our application. It's already running, up and running. Let me just open this chat app, reload it to show that it works. I have two pages, different pages opened, so I should say, for example, hello Kotlin community, send this message, and the next step should receive this message as it is right now. And I can write from here another message. Hello everyone, send it, and it should appear at the both tabs of my browser. So, which means it works, which is pretty cool. So what do we have here? We have a pretty standard app. Anton has already shown and explained in detail the structure of this app. I'm not going to be explaining in more details the code, or shall I explain it? Anton, what do you think?
I have to unmute myself before I can respond, but yeah, I think we should explain what's in there. So just to give the basic introduction.
All right. So do you see it? I guess I scaled it a little bit, so it should be more recognizable what's going on there. So it's pretty standard application. We have Gradle as a place where we configure and provide all the dependencies. We have resource folder where we can find an SQL schema for generating our database structure. We have some static files that we will be using later on, and we have our basically web view of our chat application that you just seen on my screen. The standard application properties where we can configure basically data source access and database access. As I noticed, we are using H2 for simplicity, so we are having H2 configuration here and in file database, and there is and there is three tier or three package which represents our application structure, which is services, where we have persistent message service and fake message service. We have repository, which has some representation of our domain model and standard message repository interface. And we have two controllers, as it was shown on our kind of schema of the application. In addition, since Kotlin is pretty powerful language and it offers a lot of things which reduce the amount of boilerplate that you need to write, we have an extra class called extensions, which kind of adds some extension methods to different classes like details, like message view model, like uh, database representation of the message, which allows us to easily, for example, utilize them and avoid any kind of conversion code, or kind of where you've seen this situation where we take data from one data structure and put it into another. So basically, using these extension methods, we can hide all this logic. Of course, we can get rid of it, but at least we can hide it inside extensions, which I like basically. So that's what we have in our app, and there is nothing complex, since this is pretty standard Spring Boot application. Controllers, message mapping, and that's all. Um, so what should we do first? Basically, in order to start migrating our application, we need to add a couple of important dependencies. So let's go to build Gradle. And as I mentioned, we have to replace our Spring Web MVC, which is represented as Spring Boot Starter Web, with another starter which is called Spring Boot WebFlux. So that's the first step that you may apply, and you will be getting, instead of Spring Boot Spring Web MVC, you will be getting Spring WebFlux, which brings Project Reactor underneath, which brings Reactor Netty, etc., etc. But that's not the only thing. So Spring WebFlux is just a server part of our kind of non-blocking server, but we need to add non-blocking database access. And as I mentioned, you can do that using Spring Data R2DBC. So there is Spring Boot Starter R2DBC, which allows you getting R2DBC into the project, and Spring Data R2DBC as an additional dependency. And that's basically it. One little thing that we need to add, since we don't have built-in JDBC driver carried with H2 driver, we need to replace this part basically with an extra R2DBC integration, or R2DBC driver, which provides integration with H2 database, which is called basically implementation, and it should be IO R2DBC H2. Yeah, Anton, please correct me if I did a mistake somewhere. But yeah, just saying that. So this probably should be enough to start using fully not blocking and reactive part of the Spring. However, as I mentioned, Spring is a good thing, and a part of Spring we need to bring Kotlin in place, and we need to bring Kotlin Coroutines. So for that purpose, we need to provide proper integration, and this integration is offered basically by JetBrains, and you may add one extra coroutine dependency, which looks like this. So there is Kotlin X Coroutines Reactor, which shall provide all required integrations between coroutines and Project Reactor, which means that basically that's how Spring can easily start using Kotlin coroutines, and all call features given by Kotlin language. So yeah, looks like we brought everything that we need. We got all the dependencies, and technically we can try to restart it. But yeah, and technically, let me try. It should work. Now it doesn't work. So what it says? It says that yeah, there is no Spring Boot starter R2DBC. Probably there is Spring Data uh, R2DBC. Yeah, let me quickly have a look at the dependency cheat sheet. Uh, oh yeah, I miss data here. So it's Spring Boot starter or Spring Boot data. Yeah, whatever. I just come on. Boot starter data R2DBC. So yeah, should be good. Yep. And let me restart it again. Starter. I miss starter. All right. All right. Yeah. So right now we can try to restart our app. Probably it won't work because we still depends on we fully kind of utilize blocking things, and we need to of course provide a little bit different integrations, and we need to use the main keyword which brings coroutines or enables coroutines, which is suspend. So for that purpose, kind of we brought dependencies, but a part of that we need to refactor our code a little bit. So in order to start doing something, I propose and doing refactoring basically I propose to use kind of from bottom to top refactoring. Why I propose doing kind of from bottom, from the really repository service to top? Because once we start breaking something, we will see that the compiler will help us identify the place where we need to add and change something. Because, for example, if we just do something like this, like add it, just add one suspend keyword, we kind of we will be saying, okay, we kind of enabling coroutines, like technically enabling coroutines, because we are saying that this method can be suspended at some point in time. But a part of that, nothing has changed it, and we still will be blocked by, for example, database access. So we need to add and migrate every piece of our application step by step, and doing that from the repository level will help us identify what others places we need to modify as well. So here we see a normal message repository which extends from CRUD repository. And in order to make this part fully non-blocking, unfortunately, it's not enough to just add suspend keyword. In order to kind of advertise Spring and Spring Boot that we want to have, for example, coroutines enabled, and we want to have everything asynchronous in non-blocking, we need to use a little bit different interfaces, which provides full integration with coroutines. And this interface, call it coroutines coroutines coro come on yeah coroutines CRUD repository. So this one is pretty identical to CRUD repository, except it has full integration with Kotlin Coroutines. You can see suspend function here and there. You can see even flow integration. This is another part of powerful part of Kotlin, which we'll be talking about a little bit further. But this is the thing that you have to use or should use in your Kotlin coroutine based applications in order to achieve full non-blocking messaging between your database. And then we can easily add suspend keyword, since we don't want to change the communication way with our database at this moment, and we still want to just say, okay, we want to retrieve a list of data from our database in the same way, in the same representation, but asynchronously. And for that purpose, it is just enough to add suspend keyword. So just by adding these two suspend keywords, we will see that compiler immediately says that we need to modify the other parts of our applications, which is basically our persistent message service. And since technically we can say, okay, suspend keyword here, the compiler will require us to propagate suspend uh, kind of flag to our message interface. So I propose to first add suspend keywords at our interface level and then add it to our actual implementation. So we can do it like this. And that's all we need to do. Looks pretty easy, isn't it? It is. I'm pretty sure it's all we have to do. All right. Let's move on, and let's try to compile our app again. And now we see that compiler immediately says that let's modify our HTML controller. We do the same. We just add a suspend keyword at our index, and that's it. We are good. And as you may notice, even though the message service is executing asynchronously, we can keep our code pretty imperative. And we can see that IDE kind of says that or mark this actual invocation as coroutine invocation, and it says that this one will be executed in the coroutine context asynchronously, potentially, absolutely asynchronously, and non-blockingly, of course, with the support of Spring Data RTDBC, which is good. And then the last piece that we need to modify here is our message resters. And again, the fix is pretty easy. Just let's add suspend keyword. Let's add suspend keyword. And we are done. So this is mostly almost everything that you have to do. Just add suspend keyword where it's needed. The only thing that we need to modify in addition, since we migrated from Spring Data JDBC, which is pretty standard thing in Spring ecosystem, which was there for many years. Since we migrated this part to Spring Data RTDBC, we have to modify our properties a little bit, and we need to add one extra configuration in our Spring Chat application, since Spring Data RTDBC is not that well developed. It's pretty new and fresh, and some kind of common configurations for schemas, initialization, data ingestion into database is absent at this moment. But this is actually a good chance for contributing to Spring Data for you. So please have a look and see if you can help the team. All right. As I mentioned, we need to modify a couple of things. The first one is in the application properties file. So let's go there. Here we use a standard kind of data source configuration, but as I mentioned, the Spring Data RTDBC offers a little bit different one. So we need RTDBC. Okay, I don't have the suggestion here, but I can write RTDBC URL, and I'll go to my live templates somewhere over there, and I'll try to RTDBC init, not that one. Come on, away. R2. I'll be just copying this part from my live templates, make the live either. Yeah, this one. And I'll be putting it like this. So this is the configuration that you need to do. You need to say Spring RTDBC URL, and you need to basically write down the same H2 URL as you did it before, except that instead of JDBC here, you will be specifying RTDBC. This is the main difference between configuration of normal JDBC driver and RTDBC driver. Apart of that, everything is pretty similar. And as I mentioned, we need one extra bin added in order to configure our HTML schema initialization. And this is yeah, one bean which I'm gonna be adding, but yeah, I won't be getting into much detail what it does. But as you may see, it does pretty straightforward thing. It takes it takes my schema SQL from the class paths and initialize this schema into the database. So that's what it does. Nothing pretty complex there. All right, and if I try to restart my app, it should be working. Oh, come on. What's wrong with that? Latest, latest overrides nothing. Okay. So fake message repository. Yeah, let's
Perhaps the signature in the interface doesn't match the name.
yeah, indeed. I'll be deleting this file at all since we don't need fake repository and we are not using it in this webinar at all and for this demonstration. So it's starting. Hooray, it's almost started, but something failed as usual. No property find latest found for type
Yeah,
message.
it's the other one that doesn't match this name. We have latest and I think find
Greatest.
latest.
So you mean I have to say this this in order to make it working?
No, I think it's the interface that didn't match now.
No, I haven't changed anything at the interface level.
Find latest and latest. Okay.
Yeah, it's probably I don't know, some misconfiguration of Spring data. But yeah, let me just use the older version of yeah, plugins for Kotlin and Kotlin Spring in order to make sure it's not related to the fact that I updated them. Starting? No.
No, it's the other reason.
Bin okay. Okay. No properties find latest found for type message. Probably I misconfigured then my domain model. No. Spring data. Oh, yeah, I remember it. Yeah, I remember. I'm using the wrong query. Query from Spring data JDBC, but instead of using Spring data JDBC, I need to put RDBC and I'll be good. So that's what I need to change as well. Yeah, common problem. You need to migrate not just repository interface. You also have to update your query annotation in order to make sure that Spring data finds proper thing. All right, then I can revert back the Kotlin and try to run it again. And hooray, it works. So right now I should be able to restart this app. Yeah, it's working. And say hello with Kotlin Coroutines. And in, and it's sent. And it's received. Perfect. And I can write down something like this just to make sure that it's bidirectional communication. And yeah, it is. So we just migrated, my friends, to Spring WebFlux, Spring Data RTDBC, and it was as easy as pie, just seamless with the support of Kotlin and Kotlin Coroutines, which is awesome. I like it. So, Anton, do we have any questions so far by this
I
moment?
think one good question was about actually finding the blocking calls in the call tree. Like, how do you make sure that there aren't any blocking calls in the suspending call tree?
So, that's a really good question, and the answer is basically a tool called Block Hound. This is a tool developed by a really great engineer Sergey Yegorov. You may already knew him, so here is he. And this tool basically allows you to detect a common standard places in your JVM application which causes blocking, suspension or anything related to thread blocking. And just visit it. It's under reactor slash block count org. And there is pretty straightforward instruction how to install it and how to start using it. We can actually try it, but probably we don't have enough time for doing that. So I'll quickly try it. I need to migrate all this stuff. I'll try to do that pretty quickly. Yep. And this one. I'm not sure that Spring takes or provides a bump for it. So let's try to use Gradle. Latest release. What is the latest release? 1.0.4. So in the worst case, we would need to say 1.0.4. So let's reload it again and see if it in the class pass. And what you need to do in order to make sure that your application is actually non-blocking and fully non-blocking and doesn't have anything related to blocking calls, you would need to do blockhound.install. Let's import blockhound. It's scanning. We are usually downloading and scanning the world. And nah, it's not imported yet. Probably. Okay. But it should be as easy as possible as well in order to start detecting blocking calls, and you would need to do blockhound.install and that's it. Since we don't have enough time at this webinar to play around with all the tooling, I just recommend you to go straightly to that page, take the dependency and see if it helps detecting blocking spots in your application. All right. Anything else from community?
Well, I think there is a good question about logging. Like, how do you make sure that how do you add info to the log about the context? Like, basically using the MVC to in case, like, when you have this reactive stack and coroutines switching between threads and so on.
That's a good question. As far as I know, Kotlin X provides integration, like full integration with Project Reactor. I haven't looked into detail what is in there. I can do it right now because I can. So flow as flux and probably, there is Reactor context, which coroutine context. So yeah, it is. There is integration, full integration between Reactor and Kotlin coroutines, which means that there is integration between Reactor context and coroutine context. And there is this kind of bridge which ensures that Kotlin coroutines provides and brings all propagated coroutine context into Project Reactor, Flux, and Mono.
So basically, all you need is just configure it, right? So
yes.
you need to set up the configuration for logging, and it will be there.
Yes, that's true. There is some caveats if you will be using in your application Project Reactor along with this kind of Kotlin coroutines. Then in Project Reactor, probably you would have to play around with Reactor context in order to make sure it is propagated everywhere. Unfortunately, at this moment, Project Reactor doesn't bring like kind of all cases related to context propagation coverage. But if you write your code with Kotlin and Kotlin coroutines, then this is gonna be invisible, and the context will be just propagated from Project Reactor, from Spring WebFlux, kind of downstream, and you will be just using it inside your Kotlin code.
Perfect. I think we should move on to the next part.
Yeah. So we kind of migrated to full in and blocking app. However, we still have a couple of problems, and basically these problems again can be detected at this uh, animation. So we do one time call here in order to retrieve our HTML. And as I mentioned, we do many times invocation of our message controller in order to periodically get latest message since the last observed one, which is kind of non-ideal because our application is not just a pull-based application. Our application is kind of pub-sub application, and using continuous or periodic pooling for your data is pretty inefficient because you may end up calling your server too many times and getting zero messages back because probably there are no new messages, and you will be just spinning your server CPU and wasting your resources like machine resources on doing zero job, which is not ideal. Of course our application do it, but we can do better. And basically what we need to do, we need to migrate to push data sending because we have many publishers which sends messages, and what we need to do is that message we need just to fan out this message to all the subscribers or all active other browsers which are connected to our server, to our application. So in order to do that, we need to go further and migrate to another technology which basically enable data streaming between clients and servers. And this technology is called RSocket. So this is a really cool technology. In a few words about RSocket, RSocket is a network protocol developed by greatest companies which had a lot of challenges with networking, with solving, with building different kind of microservices and doing cloud computation in different ways. And initially, the protocol was created at Netflix to solve their problems, like data streaming problems. And in few words, RSocket is open source protocol. It's layer 5, layer 6 network protocol. In the essence, it utilizes reactive streams concept. So it's basically reactive streams as a network protocol, and it allows you to control your data flow on the application level, and it supports different communication style, and it's pretty like blazingly fast because it's binary protocol, and it utilizes different transport so you can control the speed of your data sending from normal TCP to utilizing protocols like Quick or Aeron, which is great. So the RSocket ecosystem looks like this. Since this is just a network protocol, it is implemented in various languages. It is in Java, JavaScript, C++. We have RSocket Kotlin, which is a really cool implementation of RSocket protocol using Kotlin Coroutines, Tor, and it supports Kotlin native and Kotlin multi-platform. And this is basically another part of our tutorial, which we will be preparing with Anton, and you will see how powerful the Kotlin multi-platform and how powerful the powerful integration between Kotlin and RSocket. But this is another story. So right now, what we want to do, we want to migrate part of our application, and we want to add kind of RSocket into our Spring application. And fortunately, RSocket has great integration with Spring, and there is Spring messaging libraries or starter which enables RSocket in normal Spring application. And a part of that, what is great and what we already knew is that Spring is well integrated with Kotlin. And since RSocket brings reactive streams, Kotlin provides reactive streams and coroutine integration, which is just great for us. So we can start using it, and technically it shouldn't be complex migration as well. So let's just do it. And what we need to do, we need to add only one dependency, Spring messaging, in order to enable our message controller not just return pure data SLEs, but rather stream data and stream data back and forth from browser and to browser back. So that's what we need to do. Let's look inside it. This is basically the last part. Let me remove block count since it doesn't work in any case. And in order to start using Spring integration of Spring and RSocket, what you need to do, you need to just add Spring Boot Starter RSocket. Restart it, reload all the dependencies. Probably I would need to add the keyword messaging, but let's check if I have, yeah, I have RSocket already. And let me check if I have messaging. Yeah, I have Spring Boot Starter RSocket. Awesome. Great. So what you need to do in order to start migrating to RSocket, basically you have to start using Spring messaging. Unfortunately for us, migrating to Spring messaging is pretty easy task, because the only difference between Spring WebFlux is Spring messaging is that a couple of different annotations. So instead of get mapping, in order to start using Spring messaging, you would need to use message mapping, because obviously it's messaging. So you have to define message mapping instead of instead of normal get mapping, which is for REST. The second thing is that there is no REST controller in Spring messaging, so you need to say, okay, this is just a normal controller for incoming messages. There is no request mapping, so let's rewrite it to message mapping again. And RSocket has is a normal messaging protocol, and it doesn't kind of bound it or kind of limited by this HTTP style URI. So in Spring messaging, we usually use dots in order to separate your path. So I'll migrate it right immediately. So we migrated part of our controller. Instead of post mapping, we still want to have message mapping. And this kind of what we need to do in order to enable Spring messaging. But as I mentioned, along with migrating to Spring messaging, we have to migrate our application and data sending semantic from pull to push. So if we're gonna look at what we have right now, we see that we are periodically calling latest endpoint, and that's also can be noticed from our JavaScript part. I'll shortly show what's going on at the JavaScript part, just to ensure you that we are periodically pulling data from our server. And as you may see, I'm periodically with some interval calling API v1 messages in order to retrieve latest messages. So we want to go away from that part, and we want to use streaming. So it means that where is our resources? So instead of propagating our latest message ID, which is not required for data streaming case, because you should think about data streaming as a continuous pipeline which delivers messages whenever they appears. So having that kind of API, we don't need to say what was the latest messages anymore to the server, but rather we have to say, okay, server, please return me infinite list of messages. However, there is a caveat, since list is a kind of, it's a called data structure, it's a fixed data structure, it has to be filled in before sending back. We need to migrate to a different representation. And as I mentioned, Kotlin brings this representation in Kotlin Coroutines, which is called Kotlin Flow. Probably heard about Kotlin Flow, but now you see it in action. And Kotlin Flow basically represents the infinite or finite data stream of messages to which someone has to subscribe. So basically, our latest endpoint has to be renamed to stream endpoint, because technically it streams data back to our browser. And what we need to do, we don't need this code anymore. We still need message service, but message service probably has to have something similar, not latest, but rather a stream of messages, which we're gonna be returning back as a result of this method invocation. So that's what I want to have here in order to make proper API and proper semantic at the API level as well, and the implementation level. So we need to create one abstract function inside our messaging service, and that's basically it, which is going to be returning a flow. And the second part, since I mentioned that the first API was for returning latest messages, the second part was for posting messages or streaming messages from browser to a server. And technically, beforehand, we received a single message for a single invocation, which is basically inefficient because we use HTTP2 or HTTP1, and we every time create potentially a separate connection, and there is a lot of problems related to HTTP 1.1. So we want to utilize RSocket capabilities. We want to use the greatest tooling, and we want to stream messages to our server from the browser as well. So that's what we want to have. That's why we want to say, okay, instead of just posting, we want to post a stream of messages. And similarly to what we do with kind of with server to client, we want to get a flow of messages from client to server back as well. And we want to say, okay, this is inbound messages. And yeah, since we are using RSocket, we need to say that this is our payload. This is another part of Spring messaging. This is basically what we have to change on the controller level. But as you may see, a part of that we need to change our message service API. So let's go straightly there, and let's try to modify our service interface first. Since we are pushing flow of messages, we need to change it here as well. Technically, after like this API is not required anymore, so we can just simply delete it because we are not asking our server for some messages after a specific message ID anymore. We're just saying that we will be pushed by servers, so this API is redundant. However, I just want to note that the latest API is still needed because when a server is connected, we still need to return back a first few messages, and then once they are rendered, we can kind of connect to a live stream. I just want to emphasize that this is live stream of messages. This is messages which are coming once you subscribe to that flow. So you may think about this flow as a hot flow, which continuously publish messages regardless of your presence or absence as a subscriber to the stream. So this is live stream of messages. So let's name it as live stream, and I'll be using this name in here as well for consistency. And this is totally different from this one. All right, let's move to, oops. Something happened to my IDE, so I have to reopen it. Technical problems.
That's the luxury of using the EAP version at the webinars.
Yeah. Indeed, I'm using AAP because I want to try latest and greatest feature of IDE, but indeed, the downside of it is that sometimes it crashes because it's early access preview. So yeah, nevertheless, let's go back to persistent message service. And let's, come on, of course, I need to index all the stuff right now, of course. But yeah, we will try to write down some code while it indexing stuff. So as I mentioned, we get rid of message called after, and we don't need it anymore. However, instead of after, we just added another method, which is function call it live stream, and this live stream has to return flow of message VM, and we need to do something here. And of course, the post migrated to flow. Uh, so this one, and I'm not sure that this naming is a proper one. So let me find a message service again. Yeah, it's still post. So I have to change here to. Oh, come on! Everything that I did just reverted. This is unfortunate. So let me try to quickly reapply what I did before my ID crashed. So we have stream, we have flow returning here. Uh, we have persistent message service. Yeah, live stream, not just stream, but rather live stream. Yep, and we need to do something here in order to somehow return a live stream of messages. As I mentioned, post right now receiving a flow of messages, and since our save method, um, yeah, I believe that there is um, an implementation of save method which accepts a flow of messages. But as far as I remember, message repository save which accept flow of messages will be waiting until you get all the data in, which means that you would have to wait for completion of the whole stream, and only after that uh, all the messages will be stored, or the data will be persisted, which is kind of not ideal. So what I want to have here, instead of storing and doing all and giving all the job for message repository, I would like to kind of to process and do some message processing on this data stream on my own, which means that I want to do something like map here, and I want to yeah, get basically a message here. Come on, ID, please stop scanning the world. I just want to use all the feature of the ID. Please. All right. So what I want to do here, I want to yeah, take my message and do the same as here. So I want to have it as the main object, and basically the map operation has to convert my flow of messages to flow of like flow of message view models to flow of messages. So that's what I want to do with map operation. And after that, I want to say, okay, collect, and I want to start collecting messages receiving there and storing them inside message repository manually. So I want to store every message that I get. Actually, I can get rid of this kind of intermediate map stage, and I can do something like yeah, what I did here. As the main object. And that should work. So what it does basically, and what we do here, we receive a stream of messages, which in our scenario, since this is kind of a stream of messages from browser open to a server, and browser technically will be streaming these messages infinite amount of time until the web page or the tab will be closed. This flow, this stream can be treated as infinite stream of messages. That's why we need to just collect and save messages. And again, collect is so well developed, so it supports coroutines and all the stuff, so you don't have to care about these details. So you can just say message repository dot save and provide the required message for saving. Um, yeah. However, the point here, since messages are coming at this method from a particular browser, the question is how can we propagate these messages, how can we fan out all these messages to the active subscribers or other participants of this chatting. So for that purpose, in order to kind of to fan out messages, Kotlin also offers a pretty powerful mechanism. So it's also it's this mechanism is pretty experimental. Yeah, let's wait a couple of seconds for scanning to be ended. Anton, maybe there are some questions from the attendees. So
Well, there was a question just lately. Why do we just use collect and not something like on emit or on next or for each or whatever it was on each
um
and then
we
do.
can use on each. It doesn't matter. Technically, I don't remember what was it.
In fact, in the tutorial we did use on each
Okay,
with
yeah.
map and lab.
Yeah. Yeah, we even use save all. Yeah, I forgot about it. So let me just copy this part to be consistent this tutorial. I'm just saying that this part can be written in different fashion. So you can use on each, you can use just collect, which should be valid as well. I mean, you can choose the granularity of the code you write. You can kind of split every stage on a separate kind of into separate methods, and it's absolutely up to you. So you can do it through the collect, or you can write down your code like this, which is fine. Yeah, so this is a matter of style of your code, and nothing more. um okay, looks like it's finished.
I
I mean,
hope it doesn't crash again.
I hope so. All right, why doesn't parse? Okay, because I have like equal, I have unfinalized method here. So it looks like this part is kind of uh, finalized. So we convert our data, and instead of save method, which can be used as well, we use save all, which stores all the messages inside the database. I'm not quite sure which technique it uses underneath in order to store messages. Is it storing one by one as I wrote down on my own, or is it waiting for completion of all the messages? I'm not quite sure. As far as I remember, it waits for the first messages, and then it stores it, and then it takes another message and store it. So it kind of inefficient, and you can optimize it later on. But yeah, let's use it. Let's use what we have right now. And the question is, as I mentioned, how to broadcast or fan out all the incoming messages to the other participants of this chatting. And the answer is Kotlin Coroutines offers a proper tool for that, which is called broadcast. Come on,
In fact,
um,
it's not a
channel.
broadcast channel. It's not a channel anymore. When we started building this tutorial, the primary tool for doing this kind of communication or broadcasting was this broadcast channel. But in fact, if you look at the tutorial, we after the release of shared flow, we have migrated to the mutable shared flow implementation for this case.
So should I use mutable shared flow?
Yes, it should be mutable shared flow of message VMs.
Yeah, message VM. Just wondering why it doesn't. It's still analyzing something. Oh, come on, ID does so
Uh,
many things. Uh,
well, screen sharing doesn't help with the performance indeed, but we can just copy and paste probably the code and it will work.
yeah. So let's have a look. Part 5. And you say that cleanups alternate. No, at which part did you do that? Okay, maybe at this
In
one.
five part, it's five
Okay.
part five. Yeah.
Yeah, it looks like that I did the same or almost the same, except Sander. Yeah, it's still doing
Okay.
something.
Well, anyways, like I think we covered it pretty well, and people who are watching the stream know what to do if they want to try it, and you have covered different aspects of it. What we can do now is to actually in the chat there is a good question about RSocket, and I think it's better to cover that one
Okay.
instead of fighting the IDE today. So where does our RSocket fits well? What is the application area that where RSocket really shines?
So, in general, the answer is RSocket is pretty flexible. And when Ben Christensen, the person who initially created RxJava, which you probably used at Android before Kotlin, uh, so Ben Christensen, he wanted to have RSocket initially at Netflix in the case of Netflix servers communicating to the edge network, which means, in simple words, to communicate with all possible devices. Like initially, the RSocket was designed to kind of multi-purpose solution for receiving messages for absolutely different devices from browsers and requesting data as a stream of data as well as doing normal request response. And the good thing about RSocket is that RSocket supports all type of common communication. So a part of request response, which is pretty standard for yeah, REST applications or web applications of today's, RSocket supports data streaming. So you can use a single protocol in order to get the same functionality, which is kind of more straightforward in terms of usage, supports all different communications patterns, and even more. So one of them we just shown at this presentation. So you can configure your message resters, and you can say I want to receive a flow of messages in, and I want to kind of send back a flow of messages. Of course, IDE just kind of removed everything that I did, but if you look at the last part of the tutorial, you will see that yeah, let me just go to the tutorial. Spring.io. It's tutorial Spring WebFlux, Kotlin, RSocket. At the latest part, uh, you may see that for input, we specify, where is that? Yeah, for input, we say, okay, we want to receive a flow of messages and we want to return a flow of messages. But the part of that, you can say, okay, I
I
want to,
think I think you better zoom in a little bit.
yeah, is it better?
Yeah.
Okay, so technically you can say, okay, I want to receive one message in and I want to return one message out. And it's possible to do. Or you can say, okay, I just want to receive a message and I don't want to kind of provide a feedback. So this is kind of a good use case for kind of metric pushing or log pushing. So you can just throw messages to your recipient, and technically you doesn't care whether this message is dropped or not, since you are using just one way data pushing. So you can use even this type of communication, and this is all included inside RSocket. So from my standpoint, this tool is kind of pretty well suitable for all scenarios, for client to server or edge network communication, as well as for server to server, where you need to create only a single connection between two machines and do message sending back and forth, because RSocket is not just a like client to server protocol. It's peer to peer protocol, so both sides can um, can have message handlers and controllers and respond back to your messages, which is great from my standpoint, and solves many problems with today's protocol like HTTP2, since HTTP2 is still client to server, even so it has like some hacks in it in order to enable bidirectional streaming. So the protocol is pretty powerful, and yeah, chat application is a good example. But For example, another good sample of how RSocket is utilized is this Canva example. So probably you heard Canva RSocket talk from another Sergey. Uh, yeah, I don't know if there is a video here in the YouTube, but Canva as a tooling for driving Canva um, service, or how it's called. Yeah, Canva Online Design Made Easy. So they have this feature of live interaction and live modification of your I don't know what you do, but this is how they enable real time modification of the uh, drone image. So this is enabled with RSocket, which
Hmm.
allows message pushing and streaming between different machines, which is another kind of example. Also, Facebook uses RSocket for their server to server message passing. So yeah, if you use Facebook, you use probably RSocket as well.
All right. We are pretty much over time here, but I think there is another question that is worth answering,
Yeah,
which is pretty interesting one. Like how RSocket would work in case if you have multiple microservice nodes, so that you implement subscribing to messages from the backend if there would be multiple nodes for this chat app.
yeah, a good question. So um, yeah, this is basically yeah, in general, in order to start from a simple one, how you may achieve kind of multi-server communication. Technically, you may open multiple connections, and you can kind of balance and send the information um, to many services which are under the same group. And for example, at our socket Java, we have a load balancer implementation, which allows you to integrate with, for example, some discovery service, receive an information of available services, open our socket connection to them, and then execute your normal requests, but they will be load balanced between different targets. So this is one of the option which you may use in order to achieve kind of multi-cloud communication between using RSocket between many microservices. But in order to achieve what was just mentioned, like I want to stream messages to multiple servers or exchange messages between, yeah, in this scale, in RSocket there is kind of a superset project called RSocket Routing or RSocket Broker. Better name it as RSocket Broker. Let me find the repo. So RSocket routing basically is another specification for message forwarding and for broker, which is designed basically similarly to how our today's network works. So we have like our physical machines. Physical machines are connected to over the network to some other machines, which are routers, and then they have an algorithm like routing, communicating with other routers, and they can just kind of forward your message to a machine under specific IP address, and then you create with TCP a virtual tunnel and do messaging. But this initial process of finding the path to your destination, it's what our kind of network routers does. So the idea behind RSocket routing and forwarding spec is identical, allows you to use RSocket, connect to a specific machine which is broker, and then broker will kind of route your messages to specific destinations or broadcast messages to all servers under a specific group or under specific shard. And that's how you may achieve this kind of multi-server chat application where you're connected to a broker from a browser. You send a message, broker itself will fan out this message to all servers which are for example, under the group or chat or under specific tag that you configured in your route. And then these servers will fan out in turn messages to all their other browsers connected to those servers. So you have like this hierarchy when one machine are connected to another machine, and this machine creates a cluster between each other, and then kind of ensures that if you have chosen this broadcast um, type of messaging in the broker, then a broker will ensure that messages will be propagated to all other servers, and they will propagate this message to all their connected clients. So that's how you may implement this kind of advanced chat case using
All right.
RSocket routing and RSocket broker.
That was a comprehensive explanation. Thank you. I think we should wrap it up here. We are severely over time, in fact.
Indeed.
And let's recap what we have done today. So there is a new tutorial published at the Spring website. You can find it in the Spring guides page at the very bottom. Spring Boot with Kotlin and RSocket. There is a GitHub repository with the final version, with the initial and intermediate versions of the application, and the final version of with streaming with RSocket. So if you want to see the different versions, you have to switch branches, right? And probably you know how to use Git branches. I hope so. This was the first episode in our the new series of Kotlin for the server-side webinars, and 3 more are coming in March about Ktor, Helidon, and Kafka. And subscribe to our YouTube channel. You will find all the new webinars there, and you will find all kind of new videos about different aspects of Kotlin at that new YouTube channel. And it's still so many people at the broadcast. We have still a few hundred people watching it. Thank you for staying with us, and I hope it was interesting. We will be happy to receive your feedback, so stay tuned, and see you next time.
Thanks everyone, and see you.